Hello friends, welcome to Academia Science Tutoring. Today I'll start the physics classes for CBSE 10th standard students. So I'll be uploading videos for both SCRT as well as CBSE based students. So today let's start the first chapter, light, reflection and refraction. Can you imagine a world without light, without sun, the major source of energy? Of course not. Everything around us will be in dark. We won't be able to see anything around us. We won't be able to enjoy the different colors. We won't be able to see the beauty of nature. So, light is such a wonderful thing, isn't it? So, in this chapter, we'll discuss the different phenomena of light rays. What is actually light? Light is electromagnetic radiation. So, we'll discuss the different phenomena and the laws governing those in this session. For example, if we are standing in front of a mirror, why we are seeing our image back? It's due to the reflection of light. And why we are using a lens to see objects enlarged? Why we are seeing the rainbow in 7 different colors? So there are endless such things based on the properties of light. So let's look those one by one. First of all, we'll discuss the reflection of light. So why we are seeing our exact image when we are standing in front of a mirror? It's because the mirror has a highly polished surface so that when the light rays fall on it, most of the light rays get reflected back. So that's why we are seeing an exact image of us in the mirror. So it's because mirror has a highly polished surface, the light rays are getting reflected back. So to study the reflection of light, first of all we have to be aware of the laws of reflection. There are 2 laws of reflection. So the first law is the angle of incidence is equal to the angle of reflection. What is this angle of incidence and angle of reflection? So let's see that. Suppose this is a mirror. So this is the polished surface of a mirror. Suppose a light ray is incident on this polished surface and this is the normal to the point of incidence. This ray get reflected back as this mirror has a highly polished surface. So this ray get reflected back like this. So this is the incident ray and this is the reflected ray. So this is the incident ray and this is the reflected ray, and this is the normal to the point of incidence. So what is this angle of incidence and angle of reflection? Angle of incidence is the angle made by the incident ray with the normal. So the angle made by the incident ray with the normal. So this is the angle of incidence, I. And what is angle of reflection? The angle made by the reflected ray with the normal. Angle made by the reflected ray with the normal. So this is the angle of reflection R. So what does the first law says? Angle of incidence is equal to the angle of reflection. That is, angle of incidence equal to the angle of reflection. Then the second law. The second law says that the incident ray The normal to the point of incidence and the reflected ray all lie in the same plane. So, the incident ray, the normal to the point of incidence and the reflected ray all lie in the same plane. So, hope you understood the two laws of reflection. Next, we have to study the different types of mirrors. First of all, there are two types of mirrors, plane mirrors and spherical mirrors. So, first we'll see the properties of a plane mirror. For a plane mirror, the image formed will be virtual and erect. The image formed by a plane mirror will always be virtual and erect. So the first property is virtual and erect image. Virtual and erect image. The next property, the size of the image will be equal to the size of the object. The size of the image will not be diminished or it will not be enlarged. We'll get the exact size of the object. The image will be having the exact size as that of the object. So that is the second property. The next property is the distance of the object from the mirror will be equal to the distance of the image from the mirror. Okay, suppose here we have a plane mirror. Then suppose here is the object. The image will be formed behind the mirror. The size of the object and the image will be equal, and this distance also will be equal. So the distance of the image from the mirror will be equal to the distance of the object from the mirror, and the image will be formed at the back of the mirror. That's why we are saying it as a virtual image. So these are the properties of a plane mirror. The next type of mirror is the spherical mirrors, which have a spherical reflecting surfaces. So there are two types of spherical mirrors, concave mirror and a convex mirror. So let's see what is the difference between a concave mirror and a convex mirror. So this is a concave mirror which have its reflecting surface curved inwards. So this is the concave mirror, and this one is the convex mirror whose reflecting surfaces is curved outwards. So see the difference. A concave mirror has its reflecting surface curved inwards, whereas a convex mirror has its reflecting surface curved outwards. Why these are called a spherical mirror? See, it's like a part of a sphere. So these mirrors are something like a part of a sphere. It has a spherical reflecting surface. Now let's see some terms regarding this spherical mirrors. The first one is the pole. First one is pole. Pole is the center of the mirror. If this is the mirror, then pole, it is represented by the letter P. It is the center of the mirror and it lies on the surface of the mirror. So here this one will be pole P. Okay, pole is the center of the mirror which lies on the surface of the mirror. Next one is the center of curvature. What is the center of curvature? If we consider this mirror as a part of a sphere, then this sphere has a center, right? So this is the center of curvature C of this mirror. Here this one will be the center of curvature C. So for a concave mirror, the center of curvature will be in front of the mirror, whereas for a convex mirror, the center of curvature will be behind the mirror. Okay. And next is the radius of curvature. Radius of curvature is the sphere or the radius of this sphere. That is, this is the radius of curvature represented by capital letter R. So this is the radius of curvature of both these mirrors. Next we have the principal axis. Principal axis is the straight line connecting the pole and the center of curvature. So principal axis, this one. This is the principal axis, that is the straight line connecting the pole and the center of curvature. The next term is the focus. What is a focus? Suppose light rays are coming like this. It gets reflected back at the reflecting surface. Here also we have light rays. And they will intersect at a point. These reflected rays, they all will intersect at a point, and this point is the focus of the mirror. The point where the reflected rays get intersect, that is the focus of the mirror. And the focal length, the next term is focal length. Focal length is the distance between this pole and the focus. It is represented by F. F is the small f, small letter f. This is the focal length of the mirror, which is the distance between the pole and the focus. For spherical mirrors with smaller aperture, what is aperture? It is the diameter of the reflecting surface. So spherical mirrors with smaller aperture, there is a condition, that is R will be equal to double the focal length. The radius of curvature R will be equal to double the focal length. So that's the end of today's session. Hope the topics that we discussed today are clear for you. In the next session, we'll discuss the image formation in a concave mirror. And please do like, share and subscribe the channel. Thank you.